is Physics Chapter 2, Problem 75, and it reads, Heather and Jerry are standing on a bridge 50 meters above a river. Heather throws a rock straight down with a speed of 20 meters per second. Jerry, at exactly the same instant of time, throws a rock straight up at the same speed. Ignore air resistance. Part A asks how much time elapses between the first splash and the second splash. So here's a diagram of them, one throwing up, one throwing down. So we're going to start by using the equation y equals y initial plus velocity initial multiplied by t plus 1/2 multiplied by acceleration multiplied by t squared. And we're going to plug in our values for Heather because she's throwing it down. So our velocity is negative 20 meters per second. So our y final is negative 50. Our y initial is 0. Our velocity is negative 20. We're solving for our time. Plus 1/2. Our acceleration is, in this case, is negative 9.18 meters per second squared because it's gravity, and it's negative because the rock is going down, multiplied by time squared because that is what we're solving for. So we get negative 50 equals negative 20t minus 4.9t squared. So we're going to rearrange these to get them all on the same side. So we do 4.9t squared plus 20t minus 50 equals 0. And now we're going to have to use a quadratic equation to solve for that. So we go x equals negative 20 plus or minus the square root of 20 squared minus 4 times 4.9 times negative 50. And this is all over 2 times 4.9. So we get, for our time, we get it equals negative 20 plus or minus 37.14 over 9.8. And one of the values we get will be negative, and we won't use that one because time can't be negative. So we get time equals 1.75 seconds. And now we need to do the same thing for Jerry. So we're going to use the same equation and use almost the same values, except for this time our 20 will be positive. So I'm just going to start from here. So we get negative 50 equals 20t minus 4.9t squared, because the only thing we're changing is the velocity. And so that one we get x equals, or we need to rearrange them to get them all on the same side. So we get 4.9t squared minus 20t minus 50 equals 0. So we get x equals 20 plus or minus the square root of 20 squared minus 4 times 4.9 times negative 50 all over 2 times 4.9. And so this one we get 20 plus or minus 37.14 all over 9.8. And again, one of these values is negative and we won't use that one. So we get the time for this one is 5.83 seconds. And then it's asking for the time elapsed, so we need to subtract these. So we get 5.83 minus 1.75. And the time elapsed between them is 4.08 seconds. So that's for part A. And then part B says, which rock has the faster speed as it hits the water? So for that, we're going to use the equation velocity final equals velocity initial plus acceleration multiplied by time. And so we have all of these values, we just need to plug it in. So our velocity final for Heather, our velocity initial is negative 20 plus, again, negative 9.81 meters per second squared. And our time is 1.75 seconds, as we just solved. So we get that her speed is negative 37.25 meters per second. And now we'll do the same thing for Jerry using velocity final equals velocity initial plus acceleration multiplied by time. So our velocity final equals 20 plus negative 9.8 meters per second squared and times 5.83 seconds. We just solved for that. And once again, we get that his speed is also negative 37.25 7.25. So they're falling at the same speed, and